is up and ready. Okay. Allow for local development and testing. Okay, so mostly developers who are working on the like Kubernetes. Okay, if they want to do in testing, then they can use the Minikube on their local machines. Okay, and it is suitable for small scale deployment. Okay, but disadvantage is that limited scalability. So here we cannot create the HA. Why? Because it is a tool built on the Docker. Okay, so instead of creating a worker nodes or master nodes, it is creating a container and it is treating that container as a master node and the worker nodes. Okay, so it gives you limited scalability. Okay, it is not suitable for large scale or production deployment, and it also comes with a we did little customization. Okay, so these are the steps to install the Minikube. Okay, you can try it on your local. I guess you are using the Windows, so it is may or may not be possible for you. Okay, to run this test, but there is an alternative. I guess there is a Docker desktop. In Docker desktop, they have provided a Minikube. I'm not sure, but you can watch some videos regarding it, how to create it. It is very easy. Yes. Hello. Hello.
Yes, yes, yes.
Hmm.
So you want me to?
Not now, but you can watch some videos regarding this thing. Okay, so
Okay,
that it will be easy for you to uh, test it. Okay, on local.
okay,
Hmm. So search for the Minikube. Okay, if you're using like Linux, then it is very easy to install these things.
okay,
Okay, and next thing is the K3s. So K3s is similar to the Minikube. Okay, it is mainly used for the testing. Like to run the unit test cases for your application. Okay.
okay,
It is also lightweight and easy to deploy. You can just install it using this command. Okay, simply using this command, you can install it on the any server. You can try with some just create a simple machine. Okay, and try these things on that machine. Okay, while I'm not showing because it is a very easy step and I don't want to consume your time. Okay, to install giving you the all the steps because there are multiple ways and you have to explore by yourself. I'm just giving what are the ways available here. So you can
okay,
install the cluster using these simple steps. Just download it or just run this command. It will be by default installed. Use this command to get the cluster information. And second thing is uninstall. How to uninstall it. Okay, got it? Hello, hello.
yes, yes. I will try
Yes,
to install it.
yeah. And there are other alternative also called kind. It is similar to the other things. Okay, so and these are things like kind, K3s, and the Minikube. So they are mainly designed to install the cluster on your local for testing. Okay, they are not used for any production layer deployment. These are the simple tool which provide you the Kubernetes cluster for your testing. Okay,
Okay,
and next thing is the play with the Kubernetes. So it is a actual online website play with Kubernetes. So you just need to log in with your GitHub credentials and you can start running Kubernetes command here. So okay, you can also try this thing. Okay, so you need to install the cluster here. Okay, using this command, you need to initialize it.
okay,
Okay, so just explore this thing also. I'm just giving you the options. Whatever you feel comfortable, just use it. Either go with the play with Kubernetes, this online solution, okay, or else install the kind K3s or the Minikube on your local. Okay, now we are going with the how to install these things using the K3s. we are going to learn how to install a create EKS cluster in the end. Okay, once we over the Kubernetes understanding, then we are going with the EKS. Okay, I mean it is similar to the Kubernetes. Means not similar to Kubernetes. It is actually Kubernetes, but only thing is it is all thing managed by the AWS. Okay. So let's. So now I am starting with the plain Ubuntu node. Let's see, does it have the HTTP? Does it have Kubernetes? No. Does it have the Docker? Maybe it has. Okay, it has Docker, but that is nothing to do with Kubernetes. It is actually fresh VM. Okay, it doesn't have anything. It only has a Docker, but not other component. Okay, so it doesn't have the Kubernetes folder here. Okay, got it now?
Got it.
Yeah. What thing you got? Hello.
Hello.
What thing you got means?
So I will try to use AWS one.
No, but that is a different thing. That there are different ways. Okay, AWS one is the costlier one. What I'm saying for your testing, use
Hardbay, right? And your KubeADM, right?
yeah, KubeADM. Yeah, so this is the hard way. You just skip it. Just know that there is another way to install a cluster. Okay, just keep it. Just know that okay, there is some way.
Right.
With name Kubernetes hardware. Okay. Second thing is there is a cloud provider which will
Correct.
provide with the clusters automatically. Like AWS have the EKS, GCP has the GK, Azure has the AKS. Okay. Third thing is there is a means mostly if you want a production ready cluster, but without any clouds provider, then you can go with the KubeADM.
Correct.
Okay, which we are going to install now. Okay, and now there are also other options available to install the cluster on your local machines on your laptop. Okay, single node cluster. Okay, on your laptop. Okay, so go either go with Minikube, K3s, or Kind cluster. And also there is something called Play with Kubernetes, which gives you the online service. Okay, it is just a free. You will get 1 hour session, and you can directly run your commands on online without any cost. Okay, so now we are going with the KubeADM, and now we have the fresh node. Okay, got it till here? You are clear?
But now working mostly company are using the cloud based, right?
Yes, right. Yes, cloud based. Why I'm showing you so that you can understand what is happening here. Okay.
Right.
Suppose in future maybe they will tell you to create a cluster by your own. Okay, then you are going to go with this thing. Okay. So first thing is what you will do. You will launch an VM on AWS with at least like 2 GB RAM and 1 core CPU or 2 core CPU. Okay. That is the first thing. Now we have this machine. Okay, with us. Now what we'll do first, we will update the packages using this command. You're already familiar with this command, right?
Right.
Then second thing is we need to install these packages. So it is installed. Also we need to, so yeah. So third thing is we need to disable the SC Linux. Okay, so that is a requirement from the Kubernetes. We have to disable our SC Linux.
Right.
So use this command to disable the SC Linux. So at any point you are thinking, okay, it is going your head, please let me know. Okay. And then third thing is we have to disable the swap. Why? Because Kubernetes require high what you can say quicker memory. but the swap is like we are just using our hard disk as a RAM, but Kubernetes requires the uh, high memory or high throughput disk, but our hard disk is not the high throughput disk. That is why we are disabling the swap. Okay, so till here you're clear, right? Hello.
Yes, yes.
Yeah. Now next thing is we have to run this command. So these things are necessary to load some kernel modules which are required by containerd. And what is the containerd? Hello.
Hello.
What is the containerd? This currently what we are doing, we need to load this kernel modules. Okay, they are requirement for the containerd. So I am asking, what is the containerd?
Container ID.
No, no. What is the containerd? Containerd.
Container D is a daemon.
Yes, right. But what is it? We are just learn it like 50 minutes ago. We have
Yeah, this is the
mentioned it.
configuration file for the containerizations, right?
Yes, right. This is the container configuration file. But what is the containerd?
Container D is used for to create a container, right?
Right. Yeah. But it is a part of the worker node. And what does it called? What does it called?
It's called nodes.
No. It is a component of the worker node. We have learned three components. One is kubelet, second is the kubeproxy, and third was the
Kubeproxy, the CR.
right CRI, yeah, container runtime interface. Okay, so this is the plugin for the CRI. Okay, so it implements container runtime interface. Okay. So these are the required configuration for the container type. So we are now installing it. It will actually load the modules. Okay, during during the node booter. Okay. Okay, now these things are loaded. So what is the overlay module? It will allow our container to mount the file system, which is required by container runtimes. Okay, CR, like containerd and Docker to function properly. Okay, so what does it gives? It gives the ability for the container to mount a volume. Okay, or mount a file system. Okay, and this thing we are need filter module is used to enable forwarding of the packet from the page network. Okay, so it will allow the send the traffic from the node to the our containers. Okay,
Okay.
once we are done with this setting, next go to the fourth one. Here, what we are doing, we are updating our existing IP table settings. Okay, so for that we have to update this particular file. Okay, etc systemctl kubernetes conf. We are just adding the bridge network, allowing the enabling the IP forward for the IPv4. Okay, so let's do this. Apply the setting. Just we need to just reload the system. Okay. Now the steps are done. Next thing is to install the containerd. So what is the containerd? Now what is containerd? Hello. 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 Are you there?
Hello.
Yes. Are you there?
Yes, yes, yes.
Yeah. So what is the containerd?
Container ID is CRI, right? So it's a plugin installed,
Right.
right?
Plugin. Yeah. What what is its purpose? Its purpose is to create a container, delete a
Correct.
container. All these things are done by the container team. And
Correct.
now we are currently installing it using this particular
Correct.
commands. This thing will add a key, Ubuntu key. Second thing is it will add the apt repository. Then we are updating the packages of our Ubuntu. And the fourth thing is we are installing the container using this command. Okay, got it?
Got it. Got it.
Now the installation is finished. And second thing is we need to create this directory if not present, and then we just have to set this thing. Okay, in for this file etc container config.yml, and then just to restart out the container enable it.
Okay.
Then
This thing I can
status of
also take any Ubuntu machine, na? Or I can install it myself.
yeah, you can. Yes, right. You can run it on any Ubuntu machines.
Okay.
So these are the simple steps. Okay, then we are not doing anything extra. What we firstly we have done, we have installed some packages. Then we have disabled the swap and the SC Linux. Second thing, we have loaded some modules which are required by the container D. Third thing, we have enabled IPv forwarding. Okay. And fifth thing, we have installed the container D. Okay, got it now? Hello.
Okay. So it's better to take Amazon machine, or over there there is no need to just disable the swap and anything, because
No, we have to disable that swap on any machines. Currently, if you see here what you have said, launch an EC2 instance on AWS. Okay.
okay.
So these things will be similar on any machine, even if you're creating on your local using VMware, okay, or using GCP machines, okay. We have to run the same steps in every machines. And now you're got this part, na? Till installation. Hello.
Okay.
Are you getting or not? I'm just getting feeling that you are lot
No,
of
no,
conflict.
I will install later. I'm not doing. I'm getting it.
No.
I did it in past as well.
Okay.
Watch some video and try to
Mhm.
install it, and create a master node and all. Manually, I did it in past as well.
Okay. Now the next thing what you are doing. Now we have to install the KubeADM. Okay, with this version. So in the Kubernetes there are different versions. Latest is 1.26, which is released I guess in this month only. Kubernetes. So this is the latest release of the Kubernetes. So if you see here, there are this version available 23, 24, 25, 26, and 27.
Okay.
Okay, now currently it is on stable one is latest stable one is 1.26. Okay,
Okay.
so we are going to install 1.25. Okay, on this thing.
Okay.
So what we will do, export this variable. Okay, so you don't have to write this thing everywhere.
Right.
Then we will install the required packages. Then add the Kubernetes signing key. Then add the Kubernetes repository. Then update the repo. Once you are updated the repo, now what you are doing, we are going to install kubectl, kubelet, and the kubeadm. Okay, up version 1.25.0. Okay, once that is over, we can run this command kubectl version to see if the kubectl is installed or not. So here kubectl is installed, but we are getting this error because currently we don't have the cluster up and run. Okay, but here we are getting the output of the kubectl command, which is fine. It means kubectl is installed. What is a
Okay.
kubectl? What is kubectl?
Kubelet.
No. What is
Kubectl is a
kubectl?
command.
Yes, command
API
line tool.
to provide two instruction to the API, right? Server.
Yes, right. Right. It will just send a request to our API server. Okay. Now, what is kubelet?
Kubelet is responsible for creating uh, the
Pods
nodes
on that node. Pods
on
on that
the
particular node. Okay. Just verify that kubelet is installed. Okay. Now, this thing is not necessary. It means if you add hold on to this particular packages, we cannot update these packages. Kubelet. This thing you can skip it. Okay. Then second thing is enable and then start the kubelet. I guess it is already started, so we don't have to worry. Now this thing is over. So it means we have installed all the required packages. We are that is our all the prerequisites. Okay. Now next thing we have to run this command only on the master node. Okay, this thing kubedem init. It will start the creation or initialization of the cluster. Okay, so let me run this thing. Okay, so we are getting an error here. Why?
right.
Because this machine has the very low CPU.
Okay.
Yeah, the RAM is only like 2 GB and that and how to tell CPU cores? I don't remember the command now. What is it command? I don't know how to take a CPU from. Hello? Hello? Yeah. So CPU cores are 1. But for Kubernetes, we require at least 2. Okay. So number of available CPUs are 1, which is less than required 2. Okay. So for that, what we can do, we can ignore this particular error. So we can use this command for to ignore this. Just use
Okay.
this particular command to ignore this. Now just create a cluster using this now. Okay. While ignoring this particular warning.
Okay.
Remember, to create a cluster, we also need to provide a pod IP ranges. If you
Okay.
don't provide, you will get error. Not now. I will show you. Okay. Now, if you run this command, it will be fine. It will run very smoothly. There won't be any issue. It is run.
Okay.
But we are going to get a problem in future. Means after this.
Okay.
Okay. Now this process is creating a cluster. So here you can see it is doing lot of things. It is doing it in creating a PKI directory, then creating a certificate for the CA, API server, front proxy, etcd, API server again, then admin conf, it is creating kubelet conf. All these things are done by the kubedm. Okay, so all this overhead is not on our shoulder. It is done by the kubedm. Okay, but if you're going with the hard way, you have to configure all these steps. Okay, which is done by the kubedm. Okay, now our cluster is ready. And if you want to join a worker node to this cluster, what you have to do, you have to create a new machine. We have to install all of the packages till this, till the container D. Now, till here. Okay, and then once you install all these packages, you have to, you don't want don't have to run this command. You have to run the kubeadm join. Okay, got it?
Got it.
Yeah, to join a work node, you have to run this command. Okay, now next thing is it is saying us to run these commands. Okay, so we'll run these commands. Now our cluster, let's see the cluster configuration, get nodes. Okay, now we are getting this. kubectl get node. Okay, it means our cluster is installed, but here we are getting not ready. It means there is some issue in the our node. If we do, if you want to check it, just do kubectl describe node and the node name. What it is saying here, you can observe the errors, but what error does it have? So here, what it is saying, network not ready, reason network plugin not ready. Okay, so it means we forgot to install the CNI plugin. Okay, so that is our next step. Okay, so here you can see that we have 3 plugins, or there are like lot of plugins available for the CNI. Okay, it is also kind of a interface. CNI means is a container network interface. It is also a CNI, container network interface. And now we have to install the plugin for the CNI. Same like our Docker and Containerd, Kubernetes provides CNI, like container runtime interface. It also provides the container network interface, and it is for the networking purpose. Okay, so what is CNI? CNI is the rules, set of rules need to be followed by the networking plugin. Okay, so there are a lot of plugins available. If you see here, it doesn't have the list now. Yeah, here. So you can see all these links. Now, next step is now you can choose between any of 3. Okay, these 3 are popular: Flannel, Calico, and ViewNet. We are going with the Calico, I guess. Flannel. So, okay, so we are going with the Flannel. Okay, so let's install the Flannel using the this command kubectl apply, and it will give, and this is the YAML file. If you see this link now, it contains the configuration for the Kubernetes. Okay, so it is just a definition for this Planner plugin. Now just run this thing, kubectl apply. Okay, what it does in, it is creating some resources for the Kubernetes. Now if you check the status of the node, it should be ready. It will take some time. Now if you see kubectl get pods, we don't have any pods because we are currently in the default namespace. But all this setup is done in the kube system namespace. Namespace is kind of a sector. Okay, so by default we will be in the default namespace, but all the components which are required by the Kubernetes are installed in the kube system namespace. Okay, so it is creating this particular pods. Okay, but they will not be created because of some reason. Let's see their logs. If you do kubectl logs -m kube system and the pod name, you can see the logs of the pod. It is generally a debugging practice how to check a logs, okay, or how to debug a service or pod. What is the command? kubectl logs, then name system name. If you don't provide the name system, it is by default. Okay, and then the pod name. So we are getting this error, bad request, code is pod in the waiting to start. If it is not even started, then what we can do, we can describe the pod. Describe pod. Okay, so here it is saying failed to create a pod sandbox, no such a file or directory. Okay, so I already know about this error because I know what I did. I haven't provided this particular thing, pod network CIDR during the kubeadm init. That is why it is failing. Okay, so to resolve that issue, either you have to provide this during cluster initial setup, okay, this thing, or you have to do sub custom configuration. Okay, here I have mentioned that step as well. If you fail to give pod network CIDR during initialization, just run below steps. First, run this thing. Okay, it will show us the logs. Then second thing is the see if our node has the pod CIDR ranges. It doesn't have, it means we haven't set up the CIDR. We haven't provided the CIDR during the init command. So next thing is we have to update this configuration control manager. Go here and add these two lines. Once you added this thing, we have to restart a kubelet. And again, we have to restart the Flamer. So, do you have any idea about the namespace? What is namespace? Hello?
Yes.
Yeah, so what is namespace?
Sorry?
What is namespace?
Namespace used for DNS, right?
No. That namespace is different. This namespace is for the Kubernetes. So in the Kubernetes, what it does, it divides it actually categorize some pods. Okay, if you want like multiple environment, we want some pods to be in some different sector. It is kind of dividing a cluster. Okay, like setting or putting some pods in the particular box. Okay, it is like a box for different pods. Okay, if you want to separate out some pods, what you can do, we can create a namespace and put all the pods in the particular namespace. So they will not mix up. Okay, now if you see kubectl get pods -m kube system, you can see all these pods which are in the kube system namespace. If you don't provide this by default, it will use the default namespace. Okay, so what it is saying, no resource found in the default namespace. It is just like we are creating a sector and we are putting some data in it. It is a kind of isolating some pods from another pods. Okay, now if you see the kubectl get nodes, it will be ready. So this is how you install a Kubernetes cluster. You got it now? You got every point? Or yes.
So namespace is basically used for the isolate the environment, correct?
Yes, isolate environment. Like suppose now we are currently by default will be in the default namespace if you don't provide the anything here. Okay, but if you want to check the pod in the some other namespace, you have to provide -n flag and then the namespace name. Now, so currently we are seeing the pod in the kubectl namespace, and all these things are installed by the Kubernetes for us using kubeadm command. Okay, and they are mainly used for the cluster setup. So that is why they are installed in the kubectl namespace, because we don't want to see these things, right? They are only related to Kubernetes system. So that is why they are placed inside the kubectl. Okay, now if you want, like if you have different environment, then we can create a different namespace. Like kubectl create namespace, here NS means namespace, and we are giving the namespace we are giving the name to the name QA. Okay, now it is created a QA namespace. Now, if you do kubectl get pod QA, sorry, -n, you don't see any pod because we haven't created. Okay, but now this called isolation means this thing pod inside this namespace cannot directly access this. It can access, but it cannot directly access this. Okay, it is we are actually dividing the or isolating pod from another pod, because maybe there is a possibility that we want to create a some application which require 5 services, and then for other part we are creating a new application which requires 6 services, and we don't want to mix up between these three things. Okay, so better thing is to separate out this particular application by the namespace. So we are creating a namespace and we are running the pod inside a particular namespace. Now suppose I want to create a pod. Like my pod, type in a email. So it is a imperative command to create a pod with the name my pod and the image nginx. Okay, command is not. Okay, so it is created a pod. Hello. Hello. Hello.
Hello.
Hello. Are you there?
Yes, yes, yes.
Yeah, please speak, because sometimes what happens, my net goes away, so I don't know you are there or not. I will. So now, if you see kubectl get pod, we are creating a pod. Okay, it is created.
Okay.
Now, if you see kubectl get pod, yeah, can you see this pod?
Yes.
Okay. So now, if you want to create a pod in the in the other namespace, okay, then for that you have to pass the namespace -n and the namespace like QA. Now we are going to give it a QA pod. Name it as a QA pod. You can give any name, okay, or you can give my app one. If you do kubectl get pod, where is that pod? Hello?
kubectl get port, right?
Yeah, where is that pod?
It is on worker node, no?
No,
My app.
all the pod will be created in the pod worker node, but where is that pod?
I don't know.
No, but we are with concept we are learning currently.
As for the it
Namespace,
should
right?
be on some worker node, right?
Yeah, right. It will be a worker node, but we are not saying it.
Yeah, here
Why?
there is no details. So when we will do a describe port's name, then we can get the
No,
details.
but there is no pod. There is no pod with this my app name. How we can describe that pod?
My pod is showing pending stage, right?
Yeah, but where is this pod? My app one. Where is this pod?
So so you are checking on master node, right?
Yeah, means we can check on any node. Okay.
I think it's not started yet. Might be it is
No,
in.
no, but if it is not starting, then it should show it here now, because here this thing is also not started, but it is not showing here.
No idea.
Okay. So because by default we are not giving any namespace, it means we are seeing the pod inside a default namespace. Now we have created this pod in the QA namespace. Okay, so we have to provide a namespace like, and see it.
Okay.
Okay. So this is about a namespace. What we are doing, we are putting the pods in different namespace. Okay, because we don't want them to be cluttering with each other.
And its networking also will be the different, right?
Networking will be same. Only thing is we cannot directly communicate with other pods. Okay, in the other namespace, we have to use the namespace name. Okay,
Okay.
I will show you that in the when we are going to learn about the service. I will show you how to connect the other ports. It is not an issue. But you got idea about the this thing, right? What is the namespace? We have created multiple. Now, what if you want to see the ports in all namespace? Is it possible? Hello. Hello.
Yes, yes.
Is it possible to see the pod in the all namespace?
No, I think no idea. I think no.
Yes, right. You don't have it, but it is possible. You just have to provide this flag hyphen a. Hyphen a means all. So can you see all the pods now?
Yes, 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 yes.
Yeah. Okay. These are the simple Kubernetes commands. Okay. Get pods, describe pod. Now let's see. You want to describe a pod. You want to describe this my app pod. Let's see. You are going to help me. Why we are getting error? How we can resolve this?
We have to provide the namespace.
Right. Hyphen n QA.
Right.
Okay. So now we are getting this failed to schedule default scheduler. 0 of 1 nodes are available. It is because by default we cannot schedule any pod on the master node, and we only have the master node on for this particular cluster. To do kubectl get nodes, we are only seeing the master node, and because it is only master node, we cannot schedule the nodes on the master because
Correct.
what is what is the purpose of the master node? It does all the schedulings. It will do all the heavy lifting. Okay,
Only it's
creation,
managing a
deletion.
cluster. Managing a
Right.
cluster.
Yeah. So it is not a good practice to schedule the pod on the master. So by default, we are not allowed to do it. Okay. But how we debugged it? We debugged it using this command, kubectl describe pod. And here we are seeing the out 0 of 1 nodes are available. One node has the untolerated tent. Okay. This thing. So there is a concept called tent and toleration in the Kubernetes. So by default, so master node has this default tent. So because of that, scheduler will cannot schedule that pod on the master node because of that logic. Okay. Now, now, how we can do the scheduling on the master node then?
No idea, sir.
Right. Means, obviously, for any new person, it is difficult. Even for the like other person also. So we have to tolerate this thing. We have to have some toleration, or either we have to remove this particular tent from the master node. So there is a command called secure node tent and let me first tell what is the tent. So it has this particular tent. We have to run kubectl tent. And what's the main important thing? How we can search. Okay, it is showing. It is not index. Uh, So I have added it in where I added not where install. So I also created a script for you. Okay, if you want, you can use the script to install all these things. Okay, sir. So if you add this particular tent, or if you remove this particular tent from the master node, uh, not sure why it is not working. This tent name is this thing. It is unpainted. Let me see if I have this thing. I did also. Okay. So I have removed that tent. Now if you see, here get pods. It is running. Got it?
Yes.
Yeah. Why it was not running? Because by default we cannot run the pod on the master node. It has some tent. Okay, and it is not recommended to run it. Okay. So today we have learned architecture, how to install it, how to see a pod, what is the namespace, okay, how to create a pod. It's not a create a pod, you have to learn. Okay, so you are clear with this thing, how to install, what is namespace, what is the master node, what are their components. Hello.
Yes.
Okay. So now let's move toward the pod.
Right.
So the for CNI, just refer this thing. Just what is CNI? CNI is just a networking interface. Also, I have provided some ports to be open. If you want to install a multi-master setup, then you can open this port. Okay, you need to open this port on the master node and this thing on the worker node.
Okay.
Now let's go toward the workflows. Okay, now we have learned about the. Can you hear my voice? There is a heavy running in my area. Can you hear me properly? Hello.
Hello.
Yeah, can you hear me?
Yes, yes. But your voice is low. Little bit.
No. Okay.
Now.
Now let's move toward the workloads.
Okay.
Okay, so what we have seen until now is the installation concept. Okay, how to install a cluster. Now we are going to create the something containers
Okay.
on the cluster. Hmm. Now the first, so Kubernetes provide multiple resources, okay, with the different names like pod, deployment, container, init container, daemon set, stateful set. These are all things are the workloads. Workloads mean it requires a compute power and it will run a image, okay, workloads. And there is also different thing called services, volume, config maps, scaling, scaling thing resources, scheduling resources. So these are the different things. But the main thing what we require to run a container is this kind of resource type. Okay. And the first thing, anything is required or any of this workload are required is a pod. Okay. So now we are going to learn about the pod. So what is a pod? So pod is a Kubernetes resource. Okay. Now, pod is the smallest unit of the deployment in Kubernetes. Okay, so pod is the smallest unit of deployment in the Kubernetes. Okay, and it hosts for the it is a logical host for one or more container. Okay, so if you want to create any container in the Kubernetes, we create it using the pod.
Okay.
Okay, and pod can host more than one container. Okay, and it is the smallest unit of the workload in the Kubernetes. and all the container within the pod run on the same node and share the same network namespace. And pod provides a way to run the group of containers that need to work together and share same resources. It means pod can host the multiple containers. And if you want to create, if you want to run a image, or if you want to create a container, you have to go with the pod. Okay. And why do we use pod? Mainly to run a single container or multiple containers. Okay. And let's see about the pod design. So pods are designed to be ephemeral and disposable. It means we can easily create a pod. There is no memory, there is no state is required for pod. We can easily create. We can easily delete it. Okay, it is just a small compute container for us. Like like here. So it is a ephemeral. Ephemeral means suppose if you save something inside this pod. Let's see. I'm going inside pod. I'm going inside a pod. Now I'm writing something here. Vi equal. Okay. Now if I look at, okay, you can see the content, right?
Right. So
Now
SSH is used to get a command line, correct?
yes, sir. It is a, we are currently using interactive terminal mode, and we want to use the SH or bash. You can use anything.
Correct.
Go inside of that.
Okay.
Now let's see that again. You can see this. Okay. Again, we came out of, we were inside a container, created a file, and then we came out of it. Again, we went inside a container again, and the file is still there. Now, if you do like time from my file, and let's add a host name also here. Host name. Can you see this content? Okay. Now, if I came out again, I can see this thing again. Okay, it is stored on the pod. Now, if I delete this pod and create again, I delete the pod and creating it again. So the command we have used. See the pod is up and running. Now go inside the pod and look at. There is no file called test. Why? Because by default pods are ephemeral in nature. It means it doesn't have any volume attached to it. So we can easily create a pod and delete a pod. There is no attachment. There is no state storage. Nothing is stored. Even the IP is different this time. Right? See 10.24.0.6. But earlier it was, I think last thing is erased. Okay, but last time it was different. Okay. So pod is a thermal and smallest unit of the Kubernetes. So they are designed in this way. They are ephemeral and disposable. Got it? Hello.
Yes, yes.
Yeah. So it is ephemeral. Ephemeral means it doesn't store any state. Okay, nothing is stored. When we create a new pod, again it will don't remember anything about the older thing. It is actually a new container. Everything is new. They are easily created, easily disposable. Okay. Okay. Then they can create and restored dynamically by Kubernetes as needed. And this means that any data need to be persisted must be stored in the separate source such as database or workload. Okay. As we have seen, once you create a pod, we have created some file inside a pod, and when we deleted that file also went away. Right. If you want to persist that data, we have to use the volume or database. Okay. Got it?
Got it.
And pods are created from the pod templates. Okay, it means we have to define something. Like now, let's see the pod template of our pod. If you do kubectl will get pod name, my pod, and if you do -o YAML, -o means output, YAML means in YAML format. The result will be in YAML format. So if you see this, it will show us the pod template. So this is a template for our pod. So using this, you can create a pod. This template, because to create any resource in the Kubernetes, we have to provide some template. Okay, and here the template is like this. Got it?
Got it.
Now pod life cycle. As we have seen the pending one, right? When that node had that tent, that pod was in pending state. It was not in radio running state, right? Hello.
Okay.
No,
Means when we created, it's went into the pending state, correct?
yeah. Why? Because there was no other node to be scheduled. There was no node. There was no worker node. And because we cannot schedule that pod on the master node, so that is why it was in pending state. Okay. So that is also stage of the pod. Current status of the pod is running. But earlier it was pending. Right.
No.
Pending means any confusion? Hello.
Hello.
Confusion, sir.
Yes, I understood it.
So it is a status of the pod.
It's a pending. When you create it, it's pending. After pending, it went into the running mode.
When it went to running mode, that was a different thing. But why it was independent state? Because it isn't getting any scheduler in its node. Okay. So if you describe the pod, my pod one, it is saying the reason. 0 of 1 nodes are available. Okay. Got it?
Got it.
First is pending, second is running, third thing is succeeded. That thing we are going to, okay, I will show it also here also. kubectl run my pod 2 hyphen image is equal to busybox box. Here build status called container creating. So if it isn't pending, if it got the node, okay, if you schedule on some node, the next status is the container creating. Now it is running state, and this thing is crash loop and cop state. Next thing is succeeded. Succeeded, it means pod has completed its task and it container have exited normally. So in case of Docker, we have learned about the entry point. Okay, what does the entry point do? During when you create a container, it will run that entry point command. Okay, and if that entry point command is like a sleep for 2 minutes, and once that function of that particular entry point or that command is over, that container will be down. Why? Because its task is over, right? So in that case, the pod will be in succeeded state.
Okay.
And next thing is fail state. So this thing will be in fail state. We are going to say it because this one container is didn't crash to backup. Okay. After some time, this thing will be in the fail state. Okay. unknown state. Wait a minute. Pod. Now this pod 4 is running and it has the entry point sleep. It will sleep for 2 seconds. Now it is in succeeded. It means it is completed its task. Okay.
Okay.
We have added the entry point as a sleep. Sleep for 3 seconds. And after 3 seconds, it means it has that command has exited because that task was successful. Okay, so that is why it is in completed state. Can you see it here? It is completed. But this thing is running because Nginx is a server and servers will run continuously. Okay, because it has to handle the request. Right. But here my pod entry point was just to sleep for particular amount. And once that task is completed, it will be successful. Right. So that is why the status is completed. Got it?
Got it.
Give like some unknown command here. Like, so it is run container error. It is again crash loop backup. Crash loop backup means it will try to restart its container again and again.
Okay.
So here you can see the restart 5, 3, 1. So suppose if that pod is giving some error. So what Kubernetes will do? Kubernetes will try to restart that pod again and again because sometimes what happens because of some network failure, that entry point is failing or that pod is failing. So Kubernetes is very intelligent. So what it will do? It will just restart that pod again and again. Okay. Got it?
Got it. Can we stop here for today? This is almost.
Okay. Okay. Tomorrow also we'll take 2 hours lecture.
No issues. Tomorrow will be take just 2 hours.
Can you do it in the morning? At morning, when time will you be free? At least
Tomorrow we will
2 hours.
connect in morning, right?
Morning also evening because we have to cover it very quickly because it is
Okay.
taking more than 2 months. I guess it is.
Okay, no issues. We will cover.
Because we also need to cover Helm. I don't know if we are able to cover Helm or not.
Okay.
But means we are going to cover everything, that is no issue. But what happens if there is a little time? Okay.
No issue. Tomorrow we will cover 2 hours, no? So that was.
Okay. At what time you will be free in the morning, or should we do it in the at the 4 or same time?
Can we start at 10?
10. Okay, I will let you know. Okay, if you have to.
Okay, no issue. Otherwise, we will connect in evening if you are not free.
Okay. But do some practice. Okay, if you try to create a cluster locally, something so that you can get the hands-on. Because as I said, you need to do hands-on for your confidence.
Sure.
Okay, then. Bye.
Bye, sir. Bye. See you tomorrow.
See you.